Hello guys, my name is Akash and today in this video we will be discussing about the architecture fit of system integration designs. This paper introduces a measurement model for integration architectures, validated through an industrial case study. It addresses the challenges of transforming legacy systems in large enterprises by providing a simple classification approach to compare integration designs, offering guidance on selecting the best fit for specific use cases. The model helps identify problematic integrations for refactoring and supports new integration designs based on requirements. Metrics like confidentiality, availability, integrity, flexibility, throughput, and latency are used to evaluate integration designs. Initial results based on real-world testing confirm the model's effectiveness, through further research is needed for refinement. Now we'll see the introduction of this paper. In an interconnected world, information systems are critical business assets, and maintaining them is a key role of enterprise architecture, which oversees the holistic view of an organization's structure, processes, and systems. IT architects, especially in large organizations with complex legacy integration architectures, face challenges in designing optimal system integrations. Technical depth and a lack of skilled experts, as highlighted by studies such as the German for Economics Digitalization Index, hinder digital transformation. To address this, the authors propose using software measurement to assess the architecture fit of different integration designs, helping experts prioritize efforts and guiding less experienced teams towards effective designs without requiring time-consuming, in-depth analysis for each system. Methodology. The authors use a qualitative empirical approach to analyze the situation, conceptualize a solution, and validate it through real-world observations. They begin by discussing the motivation for developing a measurement approach for integration architectures, driven by their professional experiences and supported by empirical research. In section 2, they review software engineering and IT architecture approaches to create a taxonomy for classifying system integrations and define metrics to measure their quality. Section 3 details the development of the measurement model, focusing on classifying integration technologies and scoring them based on non-fictional requirements. In section 4, the authors validate their approach through a real-world case study, comparing the measurement real results with observed strengths and weaknesses. While further studies are needed, the initial results suggest the approach is valid and useful. The paper concludes by discussing the experiment's outcomes, identifying strengths, limitations, and areas for future improvement. Now see the result of this paper. The authors have worked out a clear taxonomy for integration architecture, segmentation, and classification, and have also identified meaningful metrics to measure integration architectures by referring to established software measurement practices and standards. Based on this, the authors have described a measurement model that meets the desired ease of use and has provided valid outcomes in the context of the first case study. The application was described step by step to ensure transparency and reproducibility of results. Beyond what is described in this paper, the method was applied to two additional scenarios to further increase the robustness of the research outcomes and investigate the validity of the approach. In both cases, the measurement model provided plausible results and helped to improve integration designs. This diagram categorizes data transmission methods between systems based on two factors: the initiation of transmission and the format of transmission. It distinguishes between sender-initiated and receiver-initiated transfers. Transmission formats are divided into file-based, web-based, and table-based approaches. File-based methods include exporting or importing data through file transfers like CSV exports, blob streaming, or FTP dumps. Web-based methods utilize modern technologies like REST APIs, webhooks, and event streams for data exchange. Table-based methods involve direct interaction between databases using techniques like change data capture or database connection through SQL or ODBC. The diagram illustrates the diverse ways data flows between systems depending on the architecture's needs. The current integration uses scheduled file imports, where data is extracted from system A and uploaded to system B several times a day, and vice versa. This simple approach lacks real-time synchronization, causing workflows to pause until synchronization completes. Additionally, if data is updated in both systems between cycles, one update may be overridden, compromising data integrity. To avoid this, certain fields have been made read only in one system, but this reduces operational efficiency. File compilation errors can also corrupt data or cause integration failures. To address these issues, a redesign is needed, ideally with real-time synchronization using proactive communication like web services or a database connection, combined with periodic data saving for reliability during system unavailability. This bar chart compares three integration designs: file imports, webhooks, and change data capture based on six architecture fit metrics: confidentiality, availability, integrity, flexibility, throughput, and latency. Each design's architecture fit score is represented for each metric. Overall, CDC consistently scores the highest across most metrics, especially confidentiality and latency. Webhooks perform well in flexibility and throughput, while file imports generally score lower in areas like flexibility, throughput, and latency, but moderately in integrity and availability. The chart highlights how different integration methods align with specific architectural needs. Concluding on the research outcomes, the authors observe clear evidence that the proposed approach is a valid and practical for efficiently modernizing integration landscapes. The first real-world application demonstrates that the model offers meaningful guidance for designing fit-for-purpose integration architectures and effectively measures the technical fit of integration designs. This contributes valuable insights to the enterprise architecture and software measurement communities. The authors developed a clear taxonomy for segmenting and classifying integration architectures, identifying meaningful metrics by referring to established software measurement practices and standards. Based on these insights, they created a measurement model that is easy to use and has produced valid results. In the first case study, step-by-step application ensures transparency and reproducibility. In addition to the paper's main findings, the method was applied to two further scenarios, strengthening the robustness of the research outcomes and validating the approach. In both cases, the measurement model delivered plausible results and helped improve integration designs. While the initiation outcomes are promising, the authors acknowledge the need for further refinement and maturation. Addressing the identified gaps and weakness will be the focus of future research. Thank you guys for watching my video. Hope to see you in the next one.